Hi, this is Victor and welcome back to my math tutoring video. In this video, we'll do step by step how to do integral by trigonometric substitution. When do we do integral by trigonometric substitution? If I have in my integral something that resembles to a square minus x square, I will take my x equal a sine of theta. If in my integral I have something that resembles a square plus x square, I will take my x is equal a tangent of theta. And if I have x square minus a square in my integral, I will take x equal a sec of theta. So only those three formula I want you to understand or to know by heart. And I will give you now one example and you will see what I mean. Let's take the example 9 minus x square. So the 9 is a, which is a square. So my a is 3 and minus x square. So I will take that formula because it resembles a square minus x square. So I will say, let's erase these. Let x equal 3 sine of theta. Now my dx equal 3 cosine of theta d theta. Okay? Now my integral become square root of 9 minus, instead of x here, I will put the x there. So minus 3 sine theta square. And my dx that is here become times 3 cos theta d theta. Okay? So now my integral becomes square root of 9 minus 3 square is 9 sine square of theta times 3 cosine theta d theta. And now I can factor out 9 here. So my integral become square root of 9, 1 minus sine square theta multiplied by 3 cosine theta d theta. And the 9 would go outside my square root as 3 times this 3, so it become 9. And the 9 I can put it outside my integral, become 9 square root of 1 minus sine square theta times cosine theta d theta. And this is under the square root. Okay? So now I know 1 minus square sine square of theta is equal to cosine square of theta, because I know the formula which said cosine square of theta plus sine square of theta equal to 1. So 1 minus the sine is equal to cosine square. So 9 square root of cosine square of theta times cosine of theta d theta. And now I can take out the square root and the power of 2. So it become 9 cosine theta times this cosine. So this become cosine theta times this cosine of theta. It become cosine square theta d theta. And now I know cosine square theta. I have a formula that said cosine square theta is equal 1/2 1 plus cosine 2 theta. This is from trigonometric identity. I can use this formula now. I will replace this cosine square of theta by 1/2 1 plus cosine 2 theta. The 1/2 is a constant. I'll take it outside my integral, so it becomes 9 divided by 2. 1 plus cosine 2 theta d theta. Okay? So now I distribute, I can split it out into two integrals. So it becomes 9 divided by 2 d theta plus 9 divided by 2 cosine 2 theta d theta. Or it's easier if I take out this and I put all that into big bracket. I know that I have to multiply the answer by 9 divided by 2. So integral of d theta is theta, so it becomes 9 divided by 2 theta plus integral of cosine 2 theta is equal sine 2 theta divided by 2 plus c. But I have another formula, trigonometric identity formula that said sine 2 theta equal 2 sine theta cosine theta. And those formula, I gave them in the previous video. You can watch it. I put all the formula that we need to solve the problem. I put it in a previous video. I will I forgot the name of the video, but like it is just Google Vic the math tutor and you will see all my videos, and all the videos that start with calculus 2 are the one that you need to watch if you are taking calculus 2. So applying this formula here, there it becomes 9 over 2 theta plus, instead of saying sine 2 theta, I will put 2 sine theta cosine theta divided by 2 plus c. So the 2 here and the 2 here will disappear, and my final answer will become 9 over 2 theta plus sine theta cosine theta plus c. But my problem is not resolved yet, because the variable of my original problem was x. So I had 9 minus x squared, and in my solution I don't have x, I have theta. So now I need to relate theta to x. Yeah. So here I will draw my triangle, and because at the beginning here I took let x equal 3 sine theta. So my x equal 3 sine theta. So if I divide here by 3 and I divide here by 3, so sine theta equal x over 3. And that's my theta here. And we know sine is the opposite side, which is here, which is x, divided by hypotenuse, which is 3. And there is a right angle here. And if I want to apply Pythagoras theorem, I would have here 9 minus x2. Why? Because if I have 9 minus x2 square plus x square, it should be equal to 3 square. And like if you do the calculation, you're gonna see it's gonna be equal to 3 square. So now that I have sine theta is equal x over 3, but in my, I do have sine theta, but I have cosine theta and I have theta. My cosine theta would be equal 9 minus x square adjacent divided by hypotenuse, which is 3. And my theta, it's equal arc sine x over 3. Because if sine theta is equal x over 3, my theta is arc sine x over 3. Now I go back to my solution that I wrote here, and it becomes 9 over 2. Instead of theta, I will write arc sine x divided by 3, plus instead of that sine theta here, I will put x over 3, because sine theta is equal to x over 3, times, instead of cosine theta, I will replace cosine theta by this, which is square root of 9 minus x squared divided by 3, plus c. And that's the final answer. I hope that you enjoyed that video. If you like my video, please subscribe to my channel and like my video. It will help me a lot. Thank you very much.